Additive manufacturing has been utilized to improve the design and fabrication of complex components for a wide range of applications. In this work, we introduce a novel collaborative virtual reality framework to facilitate the additive manufacturing inspection process via real-time synchronization. The development of the VR-based environment signifies a paradigm shift in the inspection and analysis of AM components. By removing the barriers to effective collaboration across geographically distributed experts and enabling a data-informed communication model using a virtual environment, we not only improve the efficiency of distributed manufacturing processes, but also set a new standard for the development and integration of the digital twins ecosystem. Our framework provides the ability to stream large-scale data, seamlessly addressing the critical issue of handling the massive datasets generated by CT scans. It also incorporates several innovative features aimed at improving the understanding and inspection of complex additively manufactured parts and processes. These features include precise alignment capabilities within the VR environment, visualization strategies for effective occlusion management, and advanced volume rendering techniques for comprehensive visualization of multimodal data. Current supported data includes design models, prescribed toolpaths, machine data, X-ray CT scans, 3D reconstructed models, and in-process images. The users can intuitively explore, analyze, and gain a comprehensive understanding of the process, which can make informed decisions to optimize the process and quality and reduce defects. The exploration and inspection features were developed via real-time synchronization. In the proposed framework, the users can draw annotations to specify the region of interest on the dataset and initiate the discussion accordingly. They could further compare results between in-process images and post-cure volume obtained from CT scans with additional information, such as prescribed toolpaths and machine toolpaths. Exploratory and semi-structured interviews were conducted with domain experts to evaluate and collect qualitative feedback. The feedback was overall positive, and they confirmed the potential benefits and applicability of integrating the framework into their workflow. The proposed framework is a promising tool to enhance the additive manufacturing process. It also opens new research directions and offers a new benchmark for integrating with digital twins.